Good morning, everybody. Good morning. Oh, so everyone's awake and had their caffeine, which is fantastic. My name's Catherine Matheson. I'm Chief Executive of the British Science Association, and I'm delighted to be opening this session today. I think on the screen behind me, there's been a series of safety instructions, which I'm promised that we won't need. But I hope you've read them just in case. I'm going to say a little bit about the British Science Association and why this topic is particularly important to us. And then I'm going to give you 4 top tips to get the most out of today. And I'm going to ask you for one favour. So we'll get to that. As many of you know, the British Science Association's vision is that we want science to be seen as a more fundamental part of culture and society. And so when we talk about it internally and to our friends and partners, we often use the analogy of football. So if you think about football, we have people who get paid to play football on one side, and you get people who hate football on the other side. I'm over here. We have those things in science too. We have people who get paid to do science, and we have people who hate science. So those two categories, if you like, are very similar. But what happens in activities like football is you have a really vibrant group of people in the middle. People who like to play football at the weekends with their friends. People who support a team and buy the T-shirt and shout at the television in the pub. And where are those people for science? What's the equivalent of buying the T-shirt or playing at the weekend? What's the equivalent of shouting at the TV or being critical or feeling like you have a voice or an opinion? So we really want to support a community of people who feels engaged with science in a different kind of way, not necessarily in a professional way, but in a more human, a more cultural way. And we've done a bit of research looking at the way that people feel engaged with science. And so for people who currently feel very unengaged, when we say to them, what does science mean to you? They say, it's a school subject. It's a thing we did at school. It's really distant from my life now. And that means that for us, education is really key. That the impressions that people get of what science is like at school will shape their experience with science for the rest of their lives. In a way, it means that for those students who don't choose science as grown-ups, they don't choose to study it or become professional scientists, their schooling is almost more important because that is the extent of their view of science. So for us, it's really crucial that we give young people opportunities to engage with science, with technology, engineering and maths, with the whole STEM collection, beyond the classroom, beyond the curriculum. And we're really fortunate to work with a really wide range of partners who help us do that, many of whom are in the room today. So this partnership, the March partnership, has been really valuable to us as part of our vision, and I'm delighted that we're going to spend the day learning from each other about how we can extend our work. I'm going to briefly give you 4 tips to get the most out of today. So one is that we have a hashtag Eurostem. So I encourage you, if you use Twitter or if you're registered with Twitter, to use that hashtag, to follow that hashtag, and then we can make even more connections than it's possible to make over coffee. It will also help us capture the themes of some of the discussions. There is free Wi-Fi. The password is behind me, very appropriately, for the Geographical Society, who are kindly hosting us today. It's my favourite Wi-Fi password of the year. Caffeine, coffee, tea and lunch are in the lower library, which is just out the door and to the right, which is where it was when you came in. And we all know how important those things are for a good conference. And the breakout sessions, you'll notice that on your badge you have a couple of numbers, and the numbers tell you which breakout session you're in. The details of the breakout sessions are in the programme. So they're my 4 tips. If you have any other questions, ask a member of BSA staff. There's a few of us standing around. Or tweet it, I guess. My favour is that you complete the evaluation forms in your pack. Not now. Don't just evaluate my bit. But as you go through the day, and particularly at the end, it really helps us to understand how we can work with partners like you even better in the future. So that's my favour. I'm going to hand over now to Claire McNulty from the British Council. Thanks.
Thanks, Catherine. Bon dia, kalimera, good morgen, goedemorgen, and I think that's probably about the limit of what I can do. But good morning and welcome. My name is Claire McNulty. I'm Director of Science at the British Council. And I want to talk to you a little bit about British Council and our science work, and also a little bit about the March programme. So, as many of you probably already know, the British Council is the UK's international cultural relations organisation. So everything that we do is about building a friendly knowledge and understanding between the UK and countries overseas. We're in more than 110 countries around the world, and we work in the areas of English language, in arts, education, society, and also really crucially, science. So when I think about why we work in science, I go back in time a bit. We've been around for more than 80 years, and about 10 years after we started, there was a conference in London in 1945, which was to establish the new UN Educational and Cultural Organisation, UNESCO. And at that time, the then Minister for Education, Ellen Wilkinson, who was one of the first female ministers actually, she proposed towards the end of the conference that actually science should be in there as well. And that's because science had played an important part during the war, but they also wanted it to play an even more important part during peacetime and be a tool for building relations, building progress, and building trust. And to connect, really crucially, following on from Catherine's point, connect scientists with the wider society, with the wider culture. And so that's why at the end of that meeting, instead of UNESCO being established, it was UNESCO. And science, ever since then, has been really part of wider culture, and I think that's a really important message to emphasise. Now, if we fast forward, there's other issues happening in the world today, meaning science and evidence particularly is even more important than ever. And to illustrate this, I've just put up there the 17 Sustainable Development Goals. Now, these are goals that are valid for every single person in the world, every single country in the world. And they're goals, 17 of them, all of which need STEM. From ending hunger to life on land to supporting life under the water, they all need STEM. Very few of them can be addressed only by STEM. So you also need integration, working with the social sciences, with humanities. But they all need that underlying evidence and the STEM skills that we're building up today. So science is even more important than ever, I think. So for us, British Council, our purpose is about using science and research to build relationships which support sustainable development and fuel future prosperity. And we work in 4 main areas. So we connect UK researchers with their counterparts overseas. We build the capacity of researchers to follow an international research career. We support public engagement activity that builds up science and adds to the impact and reach of science. And we share learning and pilot best practices around STEM education, and this is clearly an important part of that aspect of our work. So in the March project, we play a coordinating role. We have 9 partners from 7 European countries, including the UK, and for me, the UK will always be a European country, regardless of our relationship with the EU. So we're also working with Greece, Germany, Serbia, Lithuania, Bulgaria, and Portugal. And many of you are here from those countries. And the aims of the March project, you can see here, so it's to help young people to actively contribute to the learning process, and I think that's really key, that's something that's so important. It's to argue in favour of the relevance of science to everyday life. It's to promote science as a force that can build up active citizens, and to highlight the relationship between science skills and future employability. And I think throughout all of this, we're using science as a shorthand for STEM because it's just easier. So the approach in March was about scoping initially, looking at what's out there, looking at what examples of good practice there are. Then having these innovation swap workshops where people were able to exchange ideas and share experiences. Then pilot selected ideas, selected methods in different countries, because sometimes you can have a model which works fantastically in one context, but then just isn't translatable, and so this needs to be looked at. And then obviously international conferences, and this is the third of the international conferences that have been held here in London. Of course, there's a web platform to support this, and this will be ongoing, and it will be a useful tool for teachers and scientists as well, I think. So the aims of today are about disseminating the results of the project, obviously. Again, it's a continuation of that exchange of ideas around the teaching practices that have been identified. It's about bringing together you all from various countries to build up your experience, your understanding of the different innovative practices, and to think about the potential next steps. So think about the longer term sustainability of the project and the ideas that come out from it. So the themes that came out through March have been distilled into 6 key areas: learning outside the classroom, interacting with researchers, creating new media, mixing science and art, hands-on activities, and using ICT. And throughout the day, we'll be using those themes to analyse in a bit more detail the different examples and ideas that come to the table. So, as well as March, I just wanted to highlight a few other things that British Council does in this arena, in case of interest. So we do other examples of sharing international good practice. We have an online tool called Schools Online, which enables partnering with international schools. There are teacher resources around a number of issues, but including science. And so an example of this is we've been working with the Royal Society on a number of different themes connected to science. It's called Commonwealth Science Class, and there will be a webinar on it which aims to connect students from the UK and from around the world. It's not exclusive to Commonwealth countries. And it'll be on rising sea levels on the 24th of November, I think, so it might be worth you looking at that, exploring that. We also work overseas, mainly on teacher training and curriculum development. And we have a number of programmes in the various countries where we work. So the Science in Schools programme in France brings UK researchers into French schools. And there's a school lab project in Greece, which I think was one of the examples in March. It's also, this week, happens to be International Education Week. And the theme this year was Make Time for Languages. That was also why I tried to practice some of my languages at the beginning. But I think it's really important for everyone to be able to speak another language, particularly for scientists. Science is a global endeavour now, and although English is the language of science, it gives an added dimension if you're also be able to speak other languages. So I think I'd really promote that as well as the STEM for everyone. I think languages for everyone is really important. So linked to the STEM education agenda, we also work across the broader public engagement in science area. And this is because communicating science is becoming of increasing priority for researchers. They need to justify why taxpayers' money is spent on their research. But it can't just be communication one way. It has to be real two-way engagement. And I think involving non-scientists in thinking about research priorities, involving the ultimate beneficiaries of research in designing research programs, citizen science, these are all really interesting agendas moving forward. And we also know about the STEM skills shortages. So by communicating and engaging people in science, you're also inspiring the next generation of scientists and engineers. So we need to both bolster that future pipeline of scientists and engineers, but also support the downstream impact of research by engaging those beneficiaries. Just one example of some of the projects that we do in this area is FameLab. Can I just take a poll of hands, see who's heard of FameLab? It runs across quite a few countries. Great. And who knows that in many countries science teachers can apply to be on FameLab? So not so many of you. So FameLab is, crudely speaking, it's kind of X Factor for scientists, pop idol for scientists. It's about being on a stage, communicating science in a really inspiring, engaging way with just 3 minutes and no PowerPoint. And it's a way to nurture and to support really talented science communicators, be they scientists, active scientists, be they science teachers in many countries, be they working in industry, and it brings them into a really global community. So FameLab's now running in around 30 countries around the world, lots of them in Europe, but also beyond, so in Brazil, in India, in Hong Kong. And it enables people to be part of that broader global network of science communicators and share their passion and enthusiasm for science. So just to finish off, we really see science as a useful tool to engage with people from outside the UK, because it can work across boundaries of country and culture. And we work across the science and innovation landscape. So we work on the pipeline side, STEM education, sort of building up the future generation of scientists and engineers. We support research collaboration internationally, but then crucially we also support the impact and reach of that research by projects which involve public engagement of science and connecting scientists with non-scientists and the wider society. And the final slide it's a bit dark, but it's a zebrafish eye lighting up all of the sensory neurons in a zebrafish eye, just to make the point that, you know, you've got 100 billion neurons in the brain, but each one of them by themselves, it's pretty much nothing. It's just a pile of mush, 100 billion neurons. It's only when they're connected that they start working together and really exciting things happen. So that's it. Thank you.
Thanks, Claire. And that last slide reminds me of a fact I learned when I was a teenager that is still scrambling my brain. So I read somewhere that there are more potential connections between every neuron in our brain than there are atoms in the universe. I haven't really understood that yet. It's still scrambling my brain. So it's my job now to thank Claire for her presentation and to introduce our next speaker who's going to give a keynote address. So Louise Archer is Professor of Education, Communication and Society at King's College London. Louise is shaking her head, so possibly not. Close enough. And when I was looking at that earlier, I was like, that's a bit like saying Professor of everything, isn't it? There's not much that's not included in a title like that. Louise is going to tell us about the research that she's been leading called Aspires, which has really changed the way that we look at the work that we do with STEM education, and I think it will really influence the way that you look at your work as well. So, Louise?
Thank you. It's a pleasure to be here. I'm actually a professor of sociology of education, and we're going to have a bit of sociology today, but that's pretty much everything, isn't it? Yeah. Sociology covers the lot. So just to set the context that we're talking in, obviously, as we all know, lots and lots of time and effort and money has been put in to trying to work out how to engage more young people with science and STEM. But despite lots of good things happening from that, overall, it's not like we've seen a massive increase in participation. And the profile of who's doing, for example, the physical sciences and engineering, particularly in England, I'd say, hasn't really changed that dramatically over time in recent years. Lots of efforts have been trying to make science more fun and interesting, which is all good, but our research suggests that a lack of interest in science isn't just the key thing that's driving these patterns. So, as Catherine said, I'm going to talk about the Aspires project, and I'm also going to talk about the work we've been doing in the Enterprising Science project. So our Aspires project is a 10-year longitudinal study tracking young people from the age of 10 up to 18, so it's the same cohort we're following. We do large-scale surveys. As you can see, we've surveyed over 31,000 students to date, and we also do in-depth qualitative work, interviews with selected young people and their parents over time. So this is a slide some of you will be overly familiar with by now, which I trot out in every talk, but I like it. So this slide basically shows that over time, actually, lots of young people do find science interesting. So I always like to say our first group of bars there really suggests that our teachers, our science teachers, are doing a good job, because the interest in science is high in primary, the first blue bars into early secondary school. But by the time you get to the purple bar, which is when they're studying for the national examinations in year 11, when everything is really hard to maintain interest in. As you can see, still a good proportion, nearly 60%, are saying things like, I find science interesting. They also have quite strong parental support. They have quite positive views of scientists. For example, they think they do valuable work. Most also think they earn a lot of money, if scientists disagree with that. But this doesn't translate into wanting to continue on with science further. So as you see, the last little group of columns pretty much stayed the same over time. We're doing some analysis now at the moment using national pupil database data, which is pretty much showing that aspirations at year 6 are a better predictor of what you're going to be doing than aspirations at interest at year 11. So if we say, well, what do students aspire to? These are our age 15, 16-year-old students. As you can see, scientist is fairly low compared to things like business. You always have to treat this with a bit of a health warning on it, but the point it makes is there's something that feels more open and attractive to a wider range of students about business than there is about the notion of a scientist. So we've been looking in Aspires at what shapes these patterns. As you can imagine, being an academic, the answer is it's all very complex. And these are the key things that we pick out. I'm not going to talk through them all today. I'm only going to talk about the last one, but this is really just to flag that when I talk about the role of science capital, it's in the context that gender, ethnicity, careers education, the way our education systems are structured, all play a key role and can't get unpicked from that. And if you're interested in those other things, we have various publications that spell each of those areas out in a lot more detail. So I'm going to focus today on the science capital aspect. So basically, this is bringing a sociological lens to understanding science participation, and I particularly like to use the work of the French sociologist Pierre Bourdieu, hence a Bourdieusian lens. In the spirit of celebrating languages this week, this is the slightly arcane, impenetrable, obscure language of sociology that we're celebrating here today. We like to make sure no one can understand what we're talking about, if we can possibly help it. So Bourdieu suggests that it's the interaction of three things, habitus, capital and field, which shape social life and produce these patterns of participation. So habitus is basically your internal socialised layers of dispositions. It's your feel for the world. It's what produces the unspoken sense of what's normal for someone like me. And as Bourdieu said, it kind of gives you, habitus is what gives you a feel for the game. This interacts with your capital, so what resources you have. These can be cultural, economic and social. And the more you have of the right sort of resources, the better you can play the game. So essentially, if you're thinking of the game analogy, it's the hand you can play. What resources do you have that you can use? And all of this takes place in the context of field, which is a bit like social context. For Bourdieu, it's socially and historically constructed, and it really relates, it's all about power. It's about the different power positions that people have in the game. And essentially, the game is what dictates the rules. So that you've got the rules, the hand you can play, and your feel for the game. And basically, the extent of fit between these three elements shapes how you're experiencing science and science education. So some students who have a habitus that fits well, lots of capital, they will feel more like a fish in water. They don't feel the weight of the water, they can move through it and navigate easily. Others will feel more like fish out of water. So just briefly to unpick these, in terms of habitus, this is really what we are understanding is what shapes the notion that is science for someone like me, for people like us. In Aspires, we've mapped out different sorts of family habitus. So, for example, there's a quote there from a mother in one of our science families. So these are people with high science capital and a strong science habitus. And the mother's saying, you know, well, she's reflecting on, well, do we have science? Does science come into our everyday life? And she's thinking, well, the other day in the car, we were laughing about chemical symbols and things. So I guess it comes into the discussion quite subliminally, really. We all do that, obviously. And some classed, gendered, racialised habitus can fit better with the field of science. For example, when we look in science classrooms, some students are better able to do the talking science, the dominant form of talking science that we often see, which has been characterised as sort of muscular intellect, that kind of intellectual confidence, pushing other people about, asserting your views. Some students that will feel very natural for, others it won't. And it can also shape the extent to which we have, at the opposite end to our science families, those for whom science feels absent or peripheral to their lives. So whereas Davina says science is just where it's at in my family, and they literally all wear science t-shirts at the table and talk about science, you get other mothers, like the one below, saying, well, I suppose in everyday life you don't get that much to do with science. They can't see where it is. Or Jack, you know, our family, they never talk about science. Or girls like Danielle says, well, I'm not clever enough to do science, even though she really likes it and finds it interesting. So that's habitus, so that interacts with your capital, your resources that you have. And again, the more you have of the right sort, the sort that fit with the field, that are recognised, the better you can get on and stay in science, or have it as part of your everyday culture, as Catherine was talking about. So we have examples of families with high science capital. Robert M. is a boy in our Aspire study. So rather than not being able to see where science is in his life, he's lost track of how many science museums he's been to. His family subscribe to the New Scientist magazine. They like science a lot. They sit down, they watch science TV together. They talk about it at the table. His dad has a workshop. They go and do engineering in their spare time. You could probably guess his class background when he says, I mix champagne, vinegar and baking soda and try to fire a cork. He's a member of his Air Society. He's got family friends who are engineers, and most of his friends are into science. So for Robert M., science is really who he is and what he does. It's part of his habitus, and he has strong capital. And of course, Bourdieu himself didn't sully himself with thinking about science. For Bourdieu, cultural capital and social reproduction was all about high arts, les beaux-arts, high cultural artistic forms. But Bourdieu was writing in predominantly 1960s, 70s, 80s France, and we wanted to bring his conceptualisation up to date. So we think there's a lot of useful ideas that Bourdieu has, and we basically took his ideas and extended them to the context of science. And we've been trying to work out what forms of resources, of capital and habitus have the most impact on whether children continue with science or not. So we took these ideas from the Aspires project, and in the Enterprising Science project, which is a partnership with BP and the Science Museum, we've fleshed it out further. And we've proposed science capital really as this conceptual hold-all, a way of holding together all the science-related resources and dispositions and activities that children have. So your science capital comes from your socialisation, your upbringing. And how much you have will be shaped by the experiences you have at home and in schools and in out-of-school contexts. So excuse the slightly wordiness of this slide, but basically the idea is that your capital that you have isn't just enduring and has a value in and of itself. The value of it will be very much shaped and realised by the context that you're in. And this is a point that I'll come back to when I'm talking a bit more about how we do something about this. So just to put in context, to give you, we've had a bag, now let's have a candle. Let's have another analogy. If you can imagine, like, what are we talking about when we're thinking about what does it mean for young people to engage with science or not, and what affects that? In a sense, habitus and capital are a bit like a marbled candle. So if you think of a candle, habitus and capital all mixed up together, you can't really separate them out. And they're the resources, they're the stuff that can get burnt. You then may have your teacher or educational experience bringing the heat to the reaction, and the air is the field, is the context that you're in. So if we think of engagement as the flame of your candle, how bright it burns, whether it goes out after a second, if it flickers, will depend on how much oxygen, for example, is in the air, how much we can feed it, what sort of candle wax you've got to act as a resource and to feed that. And really, we're sort of trying to use this as a way to say this is why you need to look at all three aspects to understand what's going on with kids engaging with science. So, we have the candle, we have the bag. But which types of science capital are the most useful, and most importantly, what can they tell us about who's going to carry on or not, and how we can intervene or how we can help more young people continue on? So in the Enterprising Science project, we've been interested in, can we measure science capital? So we've been using surveys drawn from different sources, from Aspires, from Bourdieu, from various other work, and we've been trying to combine these together to say, well, what aspects of sort of habitus and capital can we measure? And we've piloted this in these various ways. And when we've taken across all that, we've asked about lots and lots and lots of things and then done statistical analysis to say, well, which of these is most predictive of those students who carry on or not, they really fall into these kind of 4 main dimensions or groupings of types of capital. So the first is, as you might expect, science literacy. So how much do the kids kind of understand about science, know how it works, feel confident with it, and so on. The second is science-related attitudes and values. So this is kind of the habitus aspect. So this is, do they have dispositions that, for example, see science as everywhere in everyday life or not? Do they see it as leading to lots of jobs or only to becoming a scientist? Those kind of dispositions and attitudes. The third grouping is what they're doing in their leisure time out of school. Are they reading books and magazines, watching TV, going to science centres? How often are they talking to people in their everyday lives, not just in school, about science? And the last grouping is sort of science at home, their family, knowledge and skills, if they have social contacts, if they're getting encouragement and motivation to continue with science. So there are lots and lots of, everything could be science capital, but these are the dimensions that come out the most strongly statistically. So when we did a national survey of students, we found that about 5% have high science capital, the majority have medium science capital, and quite a worryingly large percentage of 27% have low science capital. So we think there's an important thing there that we need to do to support more young people. And again, when you look at who has high or low science capital, predictably, there's a gender aspect. Boys report higher means of science capital, overrepresented in the high science capital group. Our South Asian students are scoring much higher than other groups of students. Our more affluent or middle class students are having highest science capital. And also, interesting, not surprising, our top set student we have setting very prevalently in the UK. Students in top sets have the most science capital, but students in schools which don't set have as high science capital as those in the top set, which we think is an interesting message for policy in the UK. Why set? And when you look at the relationship of science capital and, for example, planning to continue onto university, for instance, as you can see there, students with high science capital are much more likely than those with low science capital to plan to continue post-16. And they're also much more likely to have a science identity. So, for example, saying, you know, I see myself as a science person, or other people see me as a science person. So again, this is even more stark. So those with high science capital are very much have a science identity, whereas only 3% of those with low science capital. So we wanted to think, well, what can we do with this in practice, this knowledge? And so over the last year, we've been developing and piloting with teachers in London schools a science capital pedagogical approach, which we're now rolling out to schools in the north this year. So this is, as I said, part of the Enterprising Science Project. And basically, just the last group of points there is the data that we've collected around this last year. So we've basically been sitting in these classes with the teachers who've been working with us every other week, looking at what goes on in those classes, doing discussion groups with students, workshops with the teachers, interviews pre and post, and surveying the students pre and post as well to see what goes on. The basic idea behind our approach is going back to the candle. We think it's important to focus on changing the field and not the student. So we're not necessarily focusing on trying to do more things per se with the students. We were trying to change the teacher's mindset so that they changed what's valued in the field of the science classroom so they could basically help bring the students feeling closer to science. They're trying to work with what the students bring with them, and in this sense we call it a personalised and a localised approach rather than just contextualised. So it's very much valuing what the kids bring with them and then linking that to science. And it's based on Angela Calabrese Barton's assertion that if we don't value what children bring with them, then what can we expect from them in terms of engagement? So our teachers are also trying to actively cultivate those different 4 dimensions of science capital, and they're trying to challenge students' stereotypes around who does science and what counts as science. So I'm going to talk you through what we found, but I'm just to flag that the survey evidence in particular, it's so small from this pilot that we're not claiming anything statistically significant. It's really just illustrative. But we think it's interesting. So the first point to note is that we were very pleased to see over the course of the year that there were definite changes in practice. All the teachers did change their practice, and I think this is no mean feat because of what teachers have to deal with in schools anyway, so that everyone engaged really well with the project. And as you can see from the quotes there, as the teacher said, the best part has been, it really has changed how I teach. And Mr. Luca's quote is basically just saying that, she says, because with some research it's all well and good in theory, but in practice it doesn't always work. But she kept with the approach because quite quickly and early on she noticed that there were changes in her students, so she felt it was something that had some promise. All our students that we interviewed and asked when we said, has your teacher taught any different this year to how they've taught previously or compared to other teachers, they all noticed distinct changes, which they called going off topic, which we see as a very good thing. But as you can also see, they did notice the teachers teaching in line with what we were asking them to do. There's a quote there saying, my teacher, she teaches you based on what you know. So they really did pick up that the teachers were drawing on the kids' own experiences. She's linking it to jobs that we might have, and that was interesting, they're saying. And we did see a small increase in the surveys and the percentage agreeing with things like, my teachers explain how science qualifications can lead to different jobs. So the teachers were trying to build the different dimensions, and they were drawing on this personalised and localised approach. This seemed to lead to an increase in the interest and enjoyment of lessons. So, for example, some changes on the survey items in ways that we would hope. Our interview and observation data also suggested that this was happening. So you've got quotes there from teachers saying they feel their students are more engaged, makes the lessons more fun, students saying the lessons are more lively. So no bad thing there. They also reported increased attention and motivation. So, for example, students between pre and post surveys were saying they paid more attention in science lessons. And we also had teachers and students reinforcing this. So Mr. Luca was saying that her year 10, so age sort of 14, 15, bottom set science group are a very challenging group of students. She works in an inner London school, and having sat in those classes, they are a challenging group of students. But she's noticed, she says she's over the course of the year, she can see it in their eyes. They're like a meerkat. They kind of, when she does the approach, they kind of pop up, and she feels that she gets those moments of engagement, that burning of the flame, the candle burning a bit brighter, to go back to the analogy. Sociologically, we would interpret what Mr. Luca calls a meerkat moment as a reduction in dissonance between the student's habitus and the field. It's that bringing together closer with their personal backgrounds. They're seeing that more personal relevance to them. And there's a quote again at the bottom, a long quote from another one of our teachers, Mr. Okello, saying again, the big difference for him has been in the engagement and interaction with the lessons. And he's feeling that because the kids are, what they bring with them is being valued, they're much more engaged and excited, they're eager to share and eager to show. They also felt across the board that it increased student understanding. So again, we had some positive changes on some of the survey items. For example, more kids feeling that they know how to use scientific evidence to make an argument. Although this could just be the result of having another year of science teaching. But across the teachers and students, they really felt that the approach helped make science more meaningful. So lots of them would say, well, it just stays in my head more. I can understand it better. So there are lots of quotes there. So Mr. Hobbs sort of saying, you know, like before, if he tried to go over something they'd covered before, they'd be like, huh, I don't understand this. The students saying it's not like a boring way, that's to hear. And again, they often talked about it's just easier to understand when it's personalised and localised. Or Christopher thinks it's quite cool as well. So basically, as Alfie sums up, I feel we get a better understanding because we can relate to what she's teaching us. It wasn't so abstract, it wasn't so distant from them. Obviously, our schools and we, to an extent, were interested in, well, does it affect attainment at all? And there's a bit of a mixed view here. Some teachers felt it had definitely raised attainment in their classes, like Miss Dennis. But then other teachers, like Mr. Akello, said, no, it didn't actually change their attainment. But although he feels that's partly a result of the sorts of tests that they have. So mixed views on that one. It didn't lower attainment, at least. Sociologically, we were interested, well, can it change kids' dispositions? So can what you do in school change their longer-term attitudes and how they see the world? Some items seem to. So, for example, by the end of the year, more students seem to espouse the view that science skills are useful for lots of future jobs, not just scientist and doctor. So that was good from our point of view. And most of the teachers and students reported some sort of positive changes there. So the long quote from Miss Eno, it was saying that basically at the start of the previous year, she found it really hard because her students were saying, what is the point of science? There's just no point. We don't even know why we're doing it. But by the end of the year, she felt they really did know why they're doing it, and they did care. And there's just a quote from Shona as well, sort of reinforcing that point, saying that actually she can see the point of science now, so they're engaging better. We also looked in, does it change any of their out-of-school practices? And the evidence here was a bit smaller and a bit more patchy. So some teachers felt that students were coming in saying, oh, we talked about this at home last night. And there's an example there from Miss Smith saying that they, her boys talked about having discussions at the dinner table with their parents. And a few students said that they recounted using the science they'd learnt at school more in everyday life because of this year. For example, if they're going to buy a TV with their parents, whether they unplugged their phone when they're at home, whether they kept their phone on charge the whole time. Some of them started watching TED Talks and things like that more. But as Brodie says, you know, we actually use it in our lives now compared to other teachers who just tell us, then we move on. But Miss Arkwright tells us and we actually learn and implement it in our lives. Lovely Brodie, exemplifying that there. Not everyone did that, but they will. And particularly importantly for us with an equalities point of view, we found more inclusive participation in class. So this was, we were looking when we were observing for, is it only the usual suspects who speak, or does the approach help open out science participation to more students? And we did find that it, and the teachers and students agreed, that it did help broaden classroom participation. So as Mrs. Smith saying, you know, it's good for the boys who tend to get enveloped by the other boys, you know, sort of swallowed up the quieter boys. It's been good for her. She only teaches in a boys' school though. Mr. Akello, again, feels that he gets much wider participation from the students. And the students themselves talked about, well, it makes it more friendly. As Daniel says, the approach sparks more discussion. So it's more likely, more people can chime in and add in. And as the bottom student says, it brings everyone together. Everyone has something to say instead of it being just like one or two people who know the answer. And for us, getting away from that notion of science, so changing the field for these students, so it's not about knowing the right answer, but bringing your personal experience to bear on it, having a view, was really important, and that shifted participation. Importantly, it also made for happier teachers, which for us was very important. So Mr. Hobbs, for example, summed it up, said, it's made me happier as a teacher. And this was really because, I'm sure like in many of your other countries, our poor teachers here are often battling terribly difficult structures and demands for educational performativity and teaching to the test and endless audit in schools. And for many of them, this takes away from the joy of science teaching. And it provided them with a way to push back against the teaching to the test, for example. So Miss Dennis said it's helpful because Key Stage 4 is where you, before the national examinations, is where you lose kids from science. And as Mr. Hobbs said, that when that child in a class says, is this in the test, for him is the most hurtful and annoying thing. And some of our teachers recounted how they're doing the approach and they're saying something, the kid says, "So is this in the test?" And he says, "No," and they rub it out. So this notion of going off topic being a sanctioned and a legitimate way of doing science that's more inclusive was really important, and that's why we're talking about the importance of shifting the field and not just the students. Our teachers at the start said some of their colleagues were sceptical or sometimes a bit hostile to what they were doing, saying, "What are you doing? You're going to affect our results," at the start of the year. But by the end of the year, all of them were saying they'd had requests to cascade it to colleagues, and some of their colleagues were asking for training in it, and were going for other jobs by citing the approach as well. But although it's very promising, it's definitely not perfect. It's still a work in progress. Enactment of the approach by the teachers was varied. It's still developing. There's difficulty, particularly when you get towards national examinations, of making time for going off topic, as they put it. And a couple of students, two of them across the schools, were less keen and a bit sceptical, wondering if it's, as Joya says, sometimes I wonder if it's a bit of a waste of time. Like when he does one of his stories and it might take 20 minutes. But I like it at the same time. Overall, there were no changes in actual overall levels of science capital, and there was even one trend, something went the wrong way. Students seemed to arrive less on time, less likely to arrive on time for lessons by the end of the year compared to the start. So we're not saying it's perfect, but we think it is promising. And reflecting on it, I think as Paulo Freire says, hope doesn't consist in crossing one's arms and waiting. We think it's really important to get out there and try some stuff. We think there's a real importance in making small gains alongside longer-term goals. And although I'm an academic, everything's caveated, but it feels promising to us. It feels like there's something there. So we're expanding it this year with schools in the north along with the National STEM Learning Centre. So just to sum up, to reflect back, in terms of across both the projects, our implications for education. We feel there's still a need to shift policy discourse. Interest is not enough. We really want to shift that focus to how do we build science capital. And we want to shift the focus onto changing the field and not just the young people. So our science capital approach is one potential example of that. We think there are lots of inequalities alongside that. For example, careers education, for example, the way in England we structure science education, which means that these need to be addressed, because even if we inspired every single young person in England to want to continue with science, the structures we have would not allow that. They still very much filter kids out. For example, we have a system of double and triple science, which we could talk more about later if you're interested. We also think we need some more complex and nuanced understandings of inequality. What we see going on in the classrooms is really complex, and we need to support people to engage with this. It's not enough just to sort of bash people over the head and say, go out and solve this. And we also feel it's really important that we can have spaces, whether it's teachers in schools, informal educators, whoever's working in this space, to have spaces for professional reflection and to be supported to take risks, because this is a complex endeavour and it needs time and it needs support and a complex way of addressing it. So I shall finish there. Thank you. Oh, and these